Hello friends, the topic for today is utility-based agents in AI. Utility-based agents provide a more general agent framework. Such systems are characterized by utility function that maps a state or a sequence of states to a real valued utility. The agent acts so as to maximize expected utility. Then let us go to the agenda for today's video. Introduction, then utility function, goal-based agents versus utility-based agents, then expected utility, the structure of utility-based agent program design, and summary. So let us start with the introduction. Goal-based agents only distinguish between goal states and non-goal states. Goal alone are not enough to generate high-quality behavior in most environments. Goal just provide a crude binary distinction between happy and unhappy states. A more general performance measure should allow a comparison of different world states according to exactly how happy they would make the agent. Because happy does not sound very scientific, economists and computer scientists use the term utility instead. The term utility can be used to describe how happy the agent is. The word utility here refers to the quality of being useful. That is nothing but usefulness. Then let us go to the utility function. It is possible to define a measure of how desirable or useful a particular state is. This measure can be obtained through the use of utility function, which maps a state to a measure of utility of the state. An agent's utility function is essentially an internalization of the performance measure. If the internal utility function and the external performance measure are in agreement, then an agent that chooses action to maximize its utility will be rational according to the external performance measure. Then let us go to the goal-based agents versus utility-based agents. We'll have just a comparison. Like goal-based agents, a utility-based agent has many advantages in terms of flexibility and learning. Furthermore, in two kinds of cases, goals are inadequate, but utility-based agents can still make rational decisions. First, when there are conflicting goals, only some of which can be achieved. For example, speed and safety in case of taxi driver. The utility function specifies the appropriate trade-off between the two. The next, when there are several goals that the agent can aim for, none of which can be achieved with certainty. Then utility provides a way in which the likelihood of success can be weighed against the importance of the goals. Then let us go to the expected utility. Technically speaking, a rational utility-based agent chooses the action that maximizes the expected utility of the action outcomes. That is, the utility the agent expects to derive on average given a probabilities and utilities of each outcome. We show that any rational agent must behave as if it possesses a utility function whose expected value it tries to maximize. An agent that possesses an explicit utility function can make rational decisions with a general purpose algorithm that does not depend on the specific utility function being maximized. Then let us go to the structure of utility-based agent. The utility-based agent structure is shown in figure 1. So here we use rectangles to denote the current internal state of the agent's decision process and ovals to represent the background information used in the process and utility. Here the sensors are used to obtain the current prospects from the environment. Then the current prospect is combined with the old internal state to generate the updated description of the current state based on the agent's model of how the world works. It uses a model of the world along with the utility function that measures its preferences among states of the world. Then it chooses the action that leads to the best expected utility, where expected utility is computed by averaging over all possible outcome states weighted by the probability of the outcome. Then let us go to the utility-based agent program design. In utility-based agent program, we design decision-making agents that must handle the uncertainty inherent in stochastic or partially observable environments. Utility theory combines with probability theory to yield a decision theoretic agent, an agent that can make rational decision based on what it believes and what it wants. Such an agent can make decisions in context in which uncertainty and conflicting goals leave a logical agent with no way to decide. A goal-based agent has binary distinction between good and bad states, that is goal and non-goal state, while a decision theoretic agent has a continuous measure of outcome quality. Then let us go to the summary. Utility-based agents provide a more general agent framework. Then next, utility-based agents act based on not goals but also on the best way to achieve goal. Then next, in case that agent has multiple goals, this framework can accommodate different preferences for the different goals. Then next, such systems are characterized by utility function that maps a state or a sequence of states to a real valued utility. The agent acts so as to maximize expected utility. Then last, a utility-based agent has to model and keep track of its environments, tasks that have involved a great deal of research on perception, representation, reasoning and learning. So with this, we come to the end of this video. If you like the video, press the like button, share with your friends and subscribe to our channel Engineering and Technology for You. And don't forget to press the bell icon so that you get notifications for future videos on this subject. Then thanks for watching. Have a nice day.